Hi, I would like you to design object storage service like S3. You know about S3?
Yes. So basically, an object storage service. Oh, basically an object storage, right?
Yes.
Okay. So obviously, uh, if I would want to go through like some of the things which comes to my mind, maybe I will keep noting it here. What we would want to cover. Okay.
Okay.
Which are part of maybe the functional requirement, and it will try to scope our design. So in an object storage, essentially, obviously you need to have a user account or something. And let me first do this thing. Let me first describe who are the users. I think I would primarily decide it for two types of users. One is like end user, like an application or somebody who wants to store data,
Okay.
right? And other could be like admin users who manages the storage. I mean, basically the infrastructure. In this interview, I'm not sure if you want to delve into which one. Means
So
basically,
what do you mean by admin users, basically?
yeah, end users. What I meant is that basically, like an application wants to store a data, so that application becomes the end user for that storage, or ultimately it will be some application. The usage might be different.
Okay.
Okay.
But what I was asking about was admin users.
Oh, admin users. Sorry. I thought you were talking about end users. So admin users are basically who will manage that infrastructure. They might have some more rights to manage those storage rather than the end users. And they might be doing some housekeeping activities or managing the infrastructure. So that becomes more of an infra or the managing side of the whole instances and infrastructure data center.
Okay. So usually in S3 or let's say AWS Object Storage Service, you're talking about AWS employees, basically, who are the admin.
Yes.
Okay.
Yeah.
No, I don't think I want to go into that direction. I just want to have this. Let's suppose you are working in AWS and
Right.
you are creating this object storage service for your customers.
Okay. So we will just talk. We will stick to that. So first of all, whenever I am creating a service, I would have some what do you call user authentication and authorization for to allow somebody to use, or registration, you can say, module to basically allow access to a users. Now users and that registration and user profile would be created, and user profile obviously would have this can be linked to your billing for how much data, what are you storing, your limits, data limits, or maintenance, and anything with respect to managing a monetization. And so this is still, I think, this is not this is very premise of that thing. Now for an object storage, uh, here comes the actual things what you want to do. So basically you I would first want to have a system or a storage. I want to devise a storage that can hold objects, right?
Okay, what do you mean by objects here?
So objects means it is something which is binary. That means it can be image, it can be a video, it can be anything. It will be determined by the size of it, the type of it, and it will have a metadata associated with what it is.
Mm-hmm.
Okay, and now I might want to restrict what types my storage allows. So that is where because as I build, I might have limitations, or I might want to put restrictions on what I want to allow to be stored out there. Okay.
Why would you do that?
It might be due to compliance reasons. It might be due to organization. As an organization, I want to allow, say I am in the initial phase. I don't want to allow people to upload video. Means I just want to have that flexibility.
Mm-hmm. Okay.
Okay. But at a full blown storage, I think I should be able to store anything, which is binary.
Mm-hmm.
Binary or text means it can be anything. It can be a file. It can be blob, or whatever it is.
Okay.
Okay. So now secondly is access pattern to these objects. So basically, to anybody who stores the data, I need to give a handle or a URL, which is basically the destination for this storage, for them to access it. Okay. So and when somebody accesses it, I also need to give, because I am just giving a URL. So for these reads, I should be able to, when I get the read request, I should be able to return the object as is. Not maybe I might have converted it to something while storing, maybe not, but I want to give the object what is expected, what was the system which has stored it. It was stored in the same way. I need to return it as is.
Okay.
Okay. Also, I need to have some requirement about. Oh, sorry, we are in requirement. Requirement about archival and what you call hot and cold. I might want to define when is the data available instantly, or when the data is available on demand. Means it has to be. It means I might basically archive some data if it is like 2 years, 3 years old, and if the request comes for that, I should be able to. It might not be immediately available. I should have access pattern to return the data from the cold store. I had a question. Do we need to delve into this, or you want this out?
No, that's fine.
Okay. And obviously, we will need some analytics and monitoring modules for this logging and everything.
Okay.
So these are the basics I feel I would want to delve here for the functional requirements.
Mm-hmm.
We can talk about non-functional requirements if you are okay with the scope here, or you want to add or no.
No, that's fine. Let's go with the non-functional requirements now.
Okay. So non-functional, obviously this should be very highly available. That is the whole idea. If somebody has kept it at our end, it should be very highly available. If some instance is drawn, it should be directed to a replicated instance. Okay. Now talking about scalability, if it should be like if a end user, if the volume, if say volume in terms of either user or volume in terms of objects is increases, my storage should be able to sustain it or scale accordingly. Talking about performance or consistency. Now here I think since this is an object, I would want actually anybody storing it would want a strong consistency here. Oh, sorry. I think we can live with eventual consistency here, because this can be very large objects, and not somebody would want to hold on to the what do you call uh, um, upload or the storage of the whole thing if I can provide the handle at first. So providing the URL handle would be strong consistency, and the actual storage could be eventual.
What do you mean by that?
So what I mean by that is storing any metadata about the object could be strong. So metadata means what type of file, what am I storing, from whom, or what, or created date, time, or whatever. This could be strong, and so that I am able to return a URL to the application, and actual storage can be eventual. So what does that mean? That if you right away, that person or that application right away clicks the handle, that application might not see the object right away if it is still being processed or being uploaded.
Okay, but usually, what happens is that, let's suppose you have an API which you are using to upload the object.
Yes, you would want an instant.
At some point in time, the API will say success, that now the upload is complete.
Right.
But what would happen after that? Still, it will be eventually consistent at that. Because that's the point where the API returns s_OK HTTP code, which is like success. At that point, still the object, if you try to access it, it's not present because of the eventual consistency, or what would happen there?
Okay, so the way I was thinking, and I will express my thought process. The way I was thinking is that, say I'm uploading a big video, okay, and what you said is right, that ultimately at what point my API should return, right? Means if that upload is happening for some long, if I return in between, what I was trying to say is that I should be able to return immediately acknowledgement sort of a thing, that this is the URL you will be getting, and I am starting the upload. That is what I was thinking. But I can have both the models where I can look for a strong consistency, that the upload is done. That is like at least at one instance, if I can get a reply, and ultimately it will be replicated asynchronously. That could be one of the options. But I think in usual application cases, say take like I am a WhatsApp user, and I'm trying to use something object storage like this, and if I'm uploading an image or a video that has to be shared, I would definitely want that video to be uploaded. At least I get an acknowledgement that the server, one of the instance, has got that, and it will be replicated. So I would be looking at, so this is a strong consistency at that point, and beyond that is asynchronously, if eventually all instances would be consistent.
Okay.
Yeah, that's what I was thinking.
Okay. What I understand that you are saying, if you upload to one host, that is strongly consistent, but then the replication from that host to other replicas, there will be eventual consistency there, because that replication is happening asynchronously.
Yeah. I actually, okay, let me take a step back. I use the term loosely. What I meant, look, consistency, a strong consistency is basically what you're saying. Ultimately, what I'm looking for is a quorum read or quorum write. Okay, and I want a fast write. So, so I would be writing to say I have five nodes. Let's take a solid example. So I have a 5 node. Okay. 5 node cluster. So I can write here, right? So I have a 5 node cluster. So basically, I can have a quorum of 5 by 2, which is equal to 3. So in this 3, what I am referring to is that I want a fast write at this point, because the intention for somebody uploading is to write, right? Read comes later. Okay. So I in this quorum, I also don't want to get it lost that I upload it to one of the node and it crashes, so whole data is lost, right? So I might want to do with I can live with this one. So if to get a quorum of one, I can do two write plus one read.
I didn't get this part. What do you mean here? To write just one read?
To get a quorum, basically I'm looking here now. This becomes a consistency, right? So I get a look. Let me explain you this way. So what I'm saying is that say you basically need to reach three nodes to have to get a quorum that you are successful in what you are doing. Okay. So out of five, if say you are writing to three nodes, you are guaranteed that when you try to read, one of these nodes will come into picture.
Okay, why one of the node will come into picture in that case? Because you still have 5 nodes. You can read from the other 2 nodes, no?
Right.
So it's totally possible the request can go to the other 2 nodes where you haven't where the file has not yet uploaded.
Correct. No. So what I'm saying, the request can go to the other node. Oh yeah. I think I know what you're saying. I think I'm miscommunicating this one to you. That is not how I would want to do it. Because okay, let's not delve into this one. I think if I take a step back, I'm looking for a strong consistency, and when I'm looking for a strong consistency, what I meant to say is that out of these 5 nodes, I should be able to replicate at least 3 nodes if I have 5 nodes out there, and get the reply back, and if my if, I think this is what I'm saying. So if I have 5 nodes, and if I write to 3 nodes, and so 3 nodes is what I'm looking for, and if 3 writes and I need if this is there, so what does that mean? There is no way, if even if I have not written to 2 nodes, when I try to read 3, one of the node will come into picture which has the right, and I can do a read repair if those 2 nodes were the nodes where the data was not replicated.
Okay, that's fine. Let's go further.
Yeah. Okay. So this is the NFR and NFR part of it. Now,
is there any other, do you think, non-functional requirement which is important?
Okay, I talked about scalability, I talked about performance, I talked about high availability. What else is missing? Do you want to talk about like the usage? I mean, the number of users or the.
Okay, that's fine. Let's go further.
Okay. So now let's talk about the APIs. Let's start with the API structure that we would want to do here. So user registration would be a simple API. I think if you want, we can talk about it, where user is basically registering to the application, means to the our storage service.
No, that's fine. I'm interested in the APIs which are related to
the storage
requirements or functional requirements of this service.
Right. So basically, my first API would be say upload object, which takes like a user token and the object itself, which is being uploaded, some metadata about the application or whatever, and it returns URL for that thing. Okay.
Okay.
Now I would have one API to generate URL based on object ID.
I don't get it. What does it mean here? Like, what's the purpose of this one? Generate URL.
So I need to have this is an API which will not be exposed, but this will be used by my service to generate the URL to be returned back.
We are just talking about the public facing APIs.
Okay, let's not talk about this. Okay. Now I think this is my basic API. Okay, I can have update object. What that actually means is I would be replacing the object and they pass me the user token, and because there is no like update, it's like replacing the object. So they should pass me the object ID and or the URL, and I could have delete object. Okay. What else is remaining? Do we need to talk about archival or something, hot code, or we can come to it later?
Does object storage provide such APIs?
Sorry?
Does object storage provide such APIs?
Object storage provides such APIs. I'm just I haven't really extensively used them, but I'm trying to guess. Means I'm trying to design based on what I think should be there.
Mm-hmm. So what does it mean, like in that case? What the archival API would look like in that case, and what would be the purpose of that?
Oh no, not I'm not saying archival API. What I'm saying is that if I request an object, and if that object is not there, I basically what I'm saying is that basically reading an object. When I say requesting or read an object, this is what I'm saying. Read an object and an object ID. I'm saying sort of a flag to say, do you want to go to archival if this is not there? Something like that. That's what I'm saying.
You even need it. I mean, there should be just a read object API, and then under the hood, whether the object exists in the archival or some cold storage somewhere doesn't matter. Why do you need to know about it? I mean,
yeah. The reason is that, look, if it is in cold, obviously what we are thinking means how do I means there might be a lag in how I want to bring it to live environment and return. So at that point, if it is in archival, I want to return a handle to the user, or I want to hold that request that whether you want to really go that route. If it is instantaneously, yeah, I don't need it. Means behind the scenes, I should be able to get it.
I mean, I still didn't get the reasoning that you have provided. If you want to hold the handle, what do you mean by that?
Okay, so say suppose my object request comes. Okay, when my object request comes, and there is no flag or anything, and I see that the object is I am unable to query the object. Object is not there in mine, and my API or my service tells that the object is in the cold, and but what I mean cold is that it say it's on tape drive. Okay, now tape drive is an old thing, but say it is not in a it is not mounted. So somebody has to mount that data and bring it back and then return. Okay, so I just want to ensure that the user is aware that this it is not instantaneous, and the API does not times out, and the user gets to know that this is an archival data, and I provide him a handle to return back. Now it could be what I'm saying. It could be a long poll request where the user is holding to this till I return the data, or user comes back with the token later.
Okay, but still the flag I didn't get it. Like how the user will know that the object the user is requesting to be read is in
No,
cold.
user is just saying a consent that yes or no. Basically, if the object is not live, the user might not want to even want it.
Okay.
That's what it is just saying.
What are the scenarios where the user will not want this object?
Okay, so say user means it is. Let me give scenario. Sometimes it is like those things where somebody wants to fire a select star from something on a production database.
Okay.
Okay, and at that point, my default, if some user, this is an optional parameter, so my default is that it is never going to archive. It is always coming from live. So,
Okay.
so I just want to ensure that means I can have a default behavior that I always go to live and archive seamlessly. But I really want this is an extra step for me to prevent that user somebody who has fired this API knows that yes, I want to I really want this from the archive if it is not there.
No, this is I understand, but yeah, what could be a possible scenario where the user is saying, okay, only return me the object if it's not in the cold storage or not in the archive state? That I'm trying to understand. Because usually when a user upload an object, I mean, it's there so that it can be retrieved later. And when the user is requesting the object, means it wants the object. There's no need for to have this extra flag to say, okay, this is another thing now. The user now upload an object, and
Right.
that object is now, let's say, in some storage. How come a service can decide on behalf of a user that that object needs to go to archival?
Oh, this is reading, right?
Yeah, even in reading, how, I mean, user upload an object, okay, and now later the user is now calling read object to read the object.
Correct.
How the user know that, okay, or how the user need to worry even about this thing, that whether the object exists in some like hot storage or in cold storage, basically.
Okay. Look, my thought process to that was that I wanted to prevent any accidental means okay. Let me. My assumption is that bringing an object from cold to hot is not instantaneous.
Mm-hmm.
It will take some time, and some time means it might be 1 minute, 2 minutes, or it can be more.
Mm-hmm.
Okay, I don't have the SLA. SLA could be there, but I mean basically it is not instantaneous.
Mm-hmm.
Okay, it is not within a minute.
Mm-hmm.
Okay, so in that case, obviously if I am not doing, ultimately it will time out, and I have to give some response that the object is in archival. Do you need to call it? I can do that way,
Mm-hmm.
right? Or if the user I want an consent from the user that yeah, I would want, if it is not there in the hot, bring it from even if it is an archival, bring it back to me.
Okay.
It
Or
might
you
be
can,
overdoing immense, but that's means that's what I felt.
okay, but you can also have an API which is just only returns when basically the object is there or is not found, for example. So even
Yeah, yeah.
archival, the API call could be blocking, and it only returns when it's able to read the object or it is not able to find the object, maybe.
Yeah, yeah. You are saying okay. The API call itself. Yeah, API call can return for the next steps for the user, right?
Okay.
That is
Anyway, let's go further. What
okay.
else do you think?
I think this is what I am thinking should solve the basic this thing.
Okay, anything, well, but there could be like big objects basically. So how will you upload these big objects, like an object of size like size 5 GB or 6 GB or 10 GB? Like how will you upload or even read those objects?
Yeah. So usually reading those objects would be done have to be done in what you call segments or the smaller chunks, and they have to be done it parallelly, right?
Okay.
It's not that you would do it in a linear fashion, or you have to break them into like segments and then read it. So I think um, maybe like something like we do the for the videos, like adaptive byte not adaptive byte streaming, basically chunking of the videos into segments and getting it from the client side. That's how would be done, no?
Okay.
Hmm.
But what would be the APIs look like in that case?
I don't I Oh, you want the say so oh, okay. I think what you are referring, like, would I be just saying read object, or how would be the my API call would be? That's what your question, right?
Yes.
Yeah. So yeah, I don't think so. I'm able to figure that out.
Okay, that's fine. Let's go further.
Okay.
So what do you think, what would be the high level design of the service?
Right.
Yeah, let's move this on the left, maybe.
Yeah. Okay. So what I'm thinking is that I would be behind a load balancer, and this load balancer, and I would have that load balancer is the WIP, and I can have a API gateway or a proxy to determine how the my services goes and where my services are. Now for the service sites, I will definitely have the peripheral services of like analytics and monitoring or whatever, and my read object says my first service, which I think should be connected to a something like what do you call a queue, where it passes the, it's a distributed queue where it passes the segments, and that segments will ultimately land up into some processing we will do, post processing, to unify the segments and ultimately store them into the now database. Obviously this is a replicated database. This was a write service, and when I get a request for read, I will definitely want to have a cache here, some cache here, which helps me get the metadata. Basically, it will have the I can save the URLs and the pointers out here to get it from the database whenever the read request comes. So this could be my basic structure.
Okay, what is this write object is, and what is this read? This
Oh,
block?
this is our API calls to the right.
Okay, API calls, but these API calls goes to where? What are these blocks itself?
Oh, this is my service.
Okay, this is your microservice. Okay.
This is my service.
So when you want to upload an object, the call goes to this write microservice.
Yes.
And what it does with the object?
So basically it starts streaming the object to the distributed queue.
Okay, let's suppose the object was small. Let's say very small. You just insert one object here directly in the distributed queue.
Right.
And then the call returns.
Yes.
Okay, but now think about that. In the initial requirement, especially non-functional requirement, we discussed that this will be a strongly consistent.
Yes.
Now, if you are returning success here after in the write call after adding the object distributed queue.
Right.
It's totally possible you may have not processed this object in the distributed queue itself. When the read request come, like if the user after uploading the object,
you're right.
then this would be an issue. You think it against our non-social requirement?
Yeah. This does not comply to that, and yeah, basically until and unless the object goes to the database, I cannot return because and to the database, basically to the same thing. If I have a 5 node, I need to have 3 writes out there. Means through the 3 replicas. This is just one I'm shown. So essentially, until unless it is copied to 3 replicas, I should not return success. And same with read. The read should come from 3 replicas.
So what is missing now, or what would be the correct architecture in that case?
Maybe I should have a write through cache. I should have a write through cache, which when I say write through, basically no, I'm not sure what else is missing. Means that is still, even if I put a write through cache, what I am just saying is that I would have the read available for the cache, but that does not solve anything different what the queue was doing.
So what do you think in that case? What should be done?
When you say what should be done to eliminate that problem?
Yes.
You know what? Actually, this service, a distributed queue should be part of this microservice only. And when I'm writing, it should write to the database. And when it is written, it should be. I'm not sure what else is missing if I write to the database.
Okay, that's fine.
Okay,
that's fine. I think we are almost time already now.
Yeah.
So I'm going to stop the mock interview. Thank you.
Thank you.